Today we are diving into one of the biggest, most persistent problems in AI, something called catastrophic forgetting. And we're going to look at a really clever new solution called Ella that's helping AI learn without, wiping its own memory.
So let's just frame the problem with a simple question. Imagine you spent weeks training an AI to be an incredible poet. It's perfect. But now you want to teach it how to write computer code. The issue is, as it gets good at coding, it might just completely forget how to write a sonnet. And this isn't some small bug. It's a massive hurdle to building AI that can actually grow and adapt over time.
And this gets right to the heart of the issue, especially with these huge large language models, the LLMs that are basically everywhere now. They're unbelievably powerful, but they have this one glaring weakness when it comes to learning things one after another.
The official name for this is catastrophic forgetting. And honestly, the name is perfect. It's catastrophic because the memory loss isn't slow or graceful. It's sudden, and it's often a total wipeout. The model's internal wiring just gets overwritten by all the new information, pretty much erasing the old skills.
So let's just walk through what this looks like. You've got an LLM, and it's a pro at summarizing news articles. It's great. Then you decide to teach that same model a new skill. Let's say writing code. What happens? Well, it might become a pretty good coder, but its ability to summarize the news just falls off a cliff. It's like one step forward and one giant, frustrating step back.
Now, of course, this isn't a new problem. Researchers have been banging their heads against this wall for years. So before we get to this new breakthrough, let's take a quick look at some of the earlier attempts to solve this whole forgetfulness thing.
A really popular strategy was to say, okay, let's not retrain the entire billion-parameter model every single time. Instead, you use a technique like LoRA, which stands for low-rank adaptation. Think of it like plugging in these tiny specialized adapters onto the main model for each new task. You only train these little adapters, which is way faster. But you still have the same problem. The new adapters can still mess with and overwrite the old ones.
To try and stop that interference, two main schools of thought popped up. On one side, you have what are called replay methods. This is basically like constantly giving the AI flashcards of its old lessons, mixing in a little old data with the new. The huge issue? You have to store that old data, which can be a privacy nightmare or sometimes just flat out impossible. On the other side, you've got orthogonal methods, which try to build these strict digital walls, forcing the knowledge for each new skill into its own separate mathematical box. The problem there is that it's just too rigid. It stops the AI from using old knowledge to learn new things faster, and it ends up costing a ton of memory.
So both of those old approaches have some pretty serious flaws. And that's exactly what makes this new method, Ella, so exciting. It found a much, much smarter way. Ella. It stands for Efficient Lifelong Learning for Adapters. And the name really tells you everything you need to know. The whole goal is to turn an AI into a true lifelong learner, but to do it efficiently, and without it forgetting everything it knew before.
The entire philosophy behind Ella is this fundamental shift in thinking. Instead of building those rigid walls we talked about, Ella builds smart guardrails. It doesn't totally block off the old knowledge, it just gently steers the new learning process away from the most critical, important parts of what the model has already learned.
I love this analogy. Think about the AI's knowledge like a giant highway system. The most important information from past skills, those are the high-speed express lanes. So Ella comes in and acts like a smart traffic controller. When a new task shows up, Ella says, hey, look, you absolutely cannot touch these specific express lanes. They're taken. But see all these other local roads and side streets? They're all yours. You can even share some of the smaller lanes. This lets the AI completely avoid overwriting critical stuff, while still being able to reuse more general knowledge. It's brilliant.
And this approach leads to some huge advantages. It's replay-free, so you don't have to worry about storing old data. It is incredibly lightweight. It adds almost zero extra computing cost. It's scalable, meaning its memory needs don't explode as you teach it more and more things. And this is really the key. It finds that perfect sweet spot between stability, hanging on to old knowledge, and plasticity, being able to learn new things.
Okay, that all sounds fantastic in theory, right? But does it actually work in practice? Let's get to the data and see how Ella held up when it went head-to-head with other top methods. So the researchers put Ella through its paces. They took a big T5 large model and tested it across 3 different standard benchmarks. These are tests specifically designed to see how well an AI can learn a bunch of different things in a row without forgetting. And the results? Well, they're pretty spectacular. This chart here shows the final accuracy after learning all the tasks. The basic method, sequential LoRA, just tanks, getting less than 40%.
LoRA, which is a state-of-the-art wall-building method, does way better at over 71%. But Ella just sweeps in and takes the top spot with almost 80% accuracy. It set a new record for methods that don't cheat by looking at old data.
High accuracy is fantastic, but the real test, the whole point of this, is fighting that forgetfulness. So let's look at how well Ella actually remembers the things it learned early on.
So this chart shows a metric called backward transfer. It's just a fancy way of measuring how much the AI's performance on old tasks dropped after it learned new things. A higher score means it forgot less. And as you can see, Ella is clearly leading the pack here. It just does a way better job of preserving that past knowledge than any of the other top contenders.
So Ella is more accurate and it forgets less. But the final piece of the puzzle, and this is what makes it so practical for the real world, is just how incredibly efficient it is.
4.19 megabytes. That's it. That is the total amount of extra storage Ella needs to manage all of the knowledge from past tasks. That number is just tiny. And just to put that number into perspective, look at this comparison. The orthogonal method, LoRA, needs over 31 megabytes. A leading replay-based method needs a massive 147 megabytes. Ella isn't just a little more efficient, we're talking about an order of magnitude difference. That is absolutely critical when you want to actually deploy these things on real hardware.
So let's just zoom out for a second and think about what this really means. Ella isn't just some minor improvement on an algorithm. It really points to a whole new future for how AI systems can learn and adapt.
And here's why this matters to all of us. The world is not static. It is constantly changing. For an AI to be truly helpful, it can't be frozen in time, needing a complete, incredibly expensive retraining from the ground up every time there's new information. Ella gives us a practical, lightweight, and really effective way to build AIs that can be true lifelong learners, adapting on the fly to new data, new skills, and our dynamic world.
This breakthrough gets us one step closer to truly dynamic AI, and it really just leaves us with one final big question. What becomes possible when our AI companions, our assistants, and our tools are no longer stuck in the past, but can learn, grow, and adapt right there alongside us, forever?